we're going to begin studying definite integrals, which integrals is finding an area under or between curves. But before we get into it, I want to start with a very basic example. And what it says is find the area under the equation y is equal to x between x is equal to 1 and x is equal to 5. Now, when it says under, as we know, if you look at the coordinate plane, underneath y is equal to x, which is a line with the gradient of 1, is going to be infinite. So obviously below this line, you're going to go on for infinity because the line goes on for infinity and the coordinate axis goes on for infinity. But with the A-levels terminology, it says under the equation means between the line y is equal to x and the x-axis. So that's what under means. So please be careful of that. And now that we have, now that I've explained that, we can proceed. And now to find the area of this is fairly simple. We studied this last year. So you're just going to find the area of the shaded region, which I'm going to work out for you. So we're going to find the area of the triangle, and then we're going to subtract the area of the white triangle, and we're going to have the area of the shaded region. And base times height divided by 2. You've heard me say that 100 times, maybe even in the thousands. Our height is 5. Here we have 5, and we're going to divide that by 2, which is 12.5. And we found the area of the small triangle, which is a 1 by 1. So 1 times 1 is 1, and divided by 2 is 0.5. So we wind up with 12 units. So now we're going to do it the hard way, and I'm going to explain why there has to be a hard way. And we're going to do this by finding the integral. So we're going between 5 and 1. So the way the notation for integrals is, it's a little odd looking. So we are going to make this sign, and we put the maximum value on the top and the minimum value on the bottom. And you might be thinking, what's the purpose of antiderivatives? Well, you're going to find out the purpose. So the reason why we learned it last lesson is because we're going to apply it when we find integrals. Oh, I didn't realize it was still recording, sorry. Anyway, so what we're going to do now is we're going to subtract these two. We're going to subtract the maximum from the minimum. And sure enough, excuse me, we get 12.5 here, we get 0.5 here, and we wind up with 12 units. And we just did that through integration. And the reason why there has to be a difficult way when solving a problem that is this 12 squared units. And this should have been square units. But when solving a problem that's this simple, is because we're going to find areas under curved graphs and in between curved graphs. So we can't use this simple formula. We have to actually integrate.